everyone. Welcome to STG212, Protect Data and Lower Costs with Amazon EBS Snapshot. This is the last session of the day, 5:45 p.m. Thank you, everyone, for showing up here. You're just one session away from dinner. My name is Vienna Chin. I'm a Senior Product Manager with EBS Snapshot. A big part of my job is talking to customers and partners like you to understand your use case, requirements, and to build the right product. Along with me today is Kalyan.
Thank you, Vienna. Hello, everyone. My name is Kalyan Balachola. I lead the EBS Snapshot engineering team at AWS. And in my role at AWS, I have the privilege to work with many customers like you, as well as with my team, to shape and deliver the services that you all need. And I'm really excited to be here today. Back to you, Vienna.
Yep, thank you all for coming. By show of hand, how many in the audience are using snapshots today in your workload? I see a couple of you. That's great. Thank you all for being here and using Snapshot. Here's the agenda for today for what we'd like to cover. First, we'll go through some basics about what's an EBS snapshot. So for a lot of you in the audience, this will be rudimentary, but it's always good to go over the basics. Second, we'll talk about Amazon Lifecycle Manager. We like to call it DLM. Using DLM, you can automate the creation, retention, deletion, and archive of snapshots. Or next, go through two products we launched last year during reInvent, Recycle Bin and EBS Snapshot Archive. And lastly, we'll talk about Amazon EBS Direct APIs. Before we jump into what's a snapshot, let's look at the overall AWS storage portfolio. We think about our storage through three main pillars, object, block, and file. And within block storage is where Amazon EBS volumes sit. And in addition to these three main types of volumes, we also have hybrid and edge storage services and data movement services. In addition, up on top, you can see a whole slew of data services, and that's where Amazon EBS Snapshot sits in the data service. Let's take a quick look at our block offerings. We like to think about our block offerings through EC2 Instance Store and EBS volumes. For EC2 Instance Store, we have instance stores that provide SSD and HDD. For SSD, think about your i4 instance types. And for your HDD, think about your D3 instance types. And for EBS, for our SSD-backed volumes, we have GP3 and IO2. And for our HDD-backed volumes, we have ST1 and SC1 volumes. So now let's look at what's an Amazon EBS snapshot. Imagine a single availability zone. You have an EC2 instance. It's attached to an EBS volume. An EBS snapshot is a point-in-time backup of this EBS volume. It is being stored on Amazon S3. There are some key properties to remember about EBS snapshot. First, it's incremental, meaning that only the change blocks are being stored in each snapshot. Second, it's crash consistent, meaning that only completed IOs are being backed up in each snapshot. Now, let's say you run your workload where you have a single EC2 instance attached with multiple EBS volumes. Using one single API, you can create a crash consistent snapshot for all these volumes attached, or a specific subset. And lastly, for the properties of snapshot, a snapshot can be shared and copied across accounts and across AWS regions. So how do our customers use Snapshot today? Kalyan and I are really excited to learn how everyone in the audience actually uses snapshots. So if you do have the time, stay behind after the session, come talk to us. We'll love to learn more about your use case. Now, from our side, we see three main use cases that customers use Snapshot for. First is what we call EBS backup and disaster recovery, and that's how we started. Say you have an EBS volume, you take a snapshot of this volume for a daily backup. Something, let's say, bad happened to this volume, and you need to restore your workload. You can simply launch a EBS volume from this snapshot and restore. We have also seen customers increasingly copy the snapshot across account and across region for their disaster recovery practice. The second type of use case is what we like to call refresh, scale up, and data handoff workloads. Now, let's say you're a central team in an organization where you have multiple business units and multiple accounts. You want every account in your organization to run, let's say, with the same Amazon machine images, which has the latest security patching and the agents that's being approved for monitoring and logging. How we see customers do this is they will create an AMI that's backed by EBS. They will then share this AMI across all the accounts and the business unit in their organization. And this way, every account in their organization is using the latest AMI. And the last use case that we've seen customer use Snapshot for is non-EBS backup and migration. So imagine you have an on-premise corporate data center where you have a disk, and you want to back up this disk to the cloud. And you can do so with EBS direct APIs and back up this disk into a snapshot stored in S3. As you can see, Snapshot has evolved a lot since our beginnings, and we couldn't have done this without feedback and help from all the customers and partners like you. So thank you. Now let's talk about the basics. The first concept and the characteristics of Snapshot we want to talk about is the incrementality and how it exactly works. So imagine you have a 1 terabyte EBS volume. It's an empty volume, no data has been written to it. You take a snapshot of this volume, and it will be an empty snapshot. You're not getting billed for this. Now let's say you run your workloads. You write blocks 1, 2, and 3 into this volume. You take a snapshot, snapshot 1. Blocks 1, 2, and 3 will now be backed up in snapshot 1, and those are your billable blocks. Say you continue running your workload in the second day. You added blocks 4, 5, and 6. You didn't do any change to blocks 1, 2, and 3. You take your second snapshot. Now in snapshot 2, you are only billed for blocks 4, 5, and 6. These are the change blocks. Blocks 1, 2, and 3 didn't change, and hence these are called reference block because they're referenced from snapshot 1. You are actually not billed for them in snapshot 2. Similar, let's just carry this forward. You continue running your workload, blocks 7, 8, 9, get written to the volume. You take your third snapshot, and blocks 1 to 6 are referenced, and you're not billed for it. You are only billed for blocks 7, 8, and 9. And this is a very important concept to remember about snapshot incrementality, because because a snapshot is incremental, you save cost on snapshot storage because only change blocks are being stored. Not every snapshot is a full snapshot. So there are some key things to remember. Each snapshot is a full point-in-time backup. Snapshots are stored incrementally. And EBS Snapshot, for EBS Snapshot, you're only charged for written blocks. So now that we have talked about the incrementality of Snapshot, let's talk about the second property, consistency. We think about consistency in two modes, crash consistency and application consistency. Snapshot, EBS Snapshot is crash consistent, which means the snapshot will only contain the blocks of completed I/O operations. Data that sits in your, let's say, application buffer, file buffer, are not backed up in a snapshot. The mental imagery we have for crash consistency is pulling a power out of a server. Now, for the second mode, it's application consistency. How we see let's say if you take an application consistent snapshot, that means the data in your buffer is actually flushed to disk prior to taking your snapshot. How we see customer do this is they will actually have to pause your applications, flush the I/O before taking the snapshot and resume application. Now say you are running your workloads in such a way that you have a single EC2 instance with multiple EBS volumes attached. You might ask us, how can I take a crash consistent snapshot for all these volumes? We have an API called Create Snapshots, and just by using the Create Snapshots API, you can take a crash consistent snapshots for all the volumes attached. Now it's best practice, we recommend separating boot and data volumes. And this is because, let's say you actually don't need to back up your boot volumes and you want to lower your snapshot cost. And using the Create Snapshots API, you can choose to not take a snapshot of your boot volume. And this way, you actually save on your snapshot storage cost. Now let's keep this example further. Say in your data volumes, 2 are actually used for data. 1 is used for cache. You actually don't need to back up this cache volume. What we have seen customers tell us is, can you make this easier? Because today, I either have to use multiple create volume, single volume snapshot calls to take a snapshot of these 2 data volumes, or I call create snapshots API, and I have to go delete this extra data cache volume snapshots. So I'm really excited to say that in August of this year, we launched a new capability within Create Snapshots that allow you to snapshot a subset of data volumes. So what you can do is in the Create Snapshots API, you can specify the volume IDs that you don't want to take a snapshot of. So it's simple, a single API call. It's cost efficient because you're not storing any snapshots that you actually don't want. And lastly, it can be automated using Amazon Data Lifecycle Manager policies to help you specify which volume you don't want to take a snapshot of. And then in addition, you can also take application consistent snapshots of all your EBS volumes attached to a Windows EC2 instance using AWS Systems Manager's run command. The snapshot process uses Windows Volume Shadow Copy Service, VSS, which helps you to take application consistent snapshot without, let's say, any application specific backup solutions, hooks, or using your own custom scripts. So it's actually a really powerful tool if you need application consistent snapshot for your Windows workload. Now let's talk about EBS Snapshot Encryption. How we think about data protection is the most fundamental part about data protection is encryption. Now let's look at how EBS runs our encryption practice. First, we're integrated with AWS Key Management Service, KMS. Under the hood, we use AES 256 encryption. And when we say a volume is encrypted, we imply the following. Data at rest inside the volume is encrypted. Data moving between the volume and the instance are also encrypted. Any snapshots you create from this volume will continue to be encrypted, and any future volumes that you launch from this snapshot will also be encrypted. So it's actually a really powerful concept. Once a snapshot is encrypted, everything created from it will always be encrypted. Now let's look at snapshot encryption. In addition to the 2 properties we talked about with volume encryption, you can also encrypt an unencrypted snapshot when you copy the snapshot, and you can re-encrypt the snapshot you own with a different KMS key by copying the snapshot. Now, encryption is especially important because snapshots can move data between accounts and across regions. So a snapshot can be shared across account. It can be copied across account, copied within accounts, copied across AWS regions. And in addition, you can create armies that are backed by EBS snapshots. So it's especially important as a recommendation from us to encrypt your snapshots because of these data movements. Now, we would like to share some best practices for sharing snapshots. So by default, snapshots are not shared. You have to enable sharing with either specific accounts or publicly. For public sharing, it is a reasonable use case if you're listing your armies in the AWS marketplace. But in general, for a majority of the customer use case we see, you actually don't need public sharing. You just need to share it with specific accounts. And for best data protection practice and not leak your data publicly, we recommend checking whether or not your snapshots are shared publicly. So on the left, you can see on the console, it's in the modify permission. For a snapshot, you can see that this one is shared publicly. And on the CLI, it's the modify snapshot attributes API, where you look at the create volumes permissions. When it's group all, it means the snapshot is being shared publicly. So if you are concerned about public sharing of snapshot, do take action items to check. And in addition, for sharing within the same region, you can share snapshot and AMIs without being billed for multiple full snapshot. So if you're thinking about cost optimizing your snapshot storage cost for within region, you can think about sharing snapshots instead of copying. And in addition, to launch a volume from a snapshot copy must be in the region. And this is especially important when you think about across region. You have to copy the snapshot to your second region in order to launch a volume in your second region. Now that we have talked about sharing snapshot, let's look at copy snapshot. We have seen customers increasingly use snapshot, copy it across account and across region for their disaster recovery practice. And in addition to copying the snapshot to protect against region-wide disasters, we see customers lock down on their resource level permissions in the target snapshot copy. And they also do a permission lockdown to protect against malicious or unintentional delete of data. So we see snapshot being increasingly incorporated into DR practice. Now, you might ask me, encryption sounds great. How do I enforce it? A common use case we see is, let's say you are the central security team in a large organization. You are asked to enforce encryption throughout hundreds, thousands of accounts. And it's really hard because some of these accounts are individual, some of these are third parties. How do I have an easy way to do so? And EBS has a feature called EBS Encryption by default. It can be enabled on a per account, per region level. And once this feature is enabled, everything created in this account will be encrypted. So all your new volumes launched in this account, all your snapshots, all your future AMIs will by default be encrypted. And it's just a simple click in the console, or if you prefer CLI, the API or a simple API call. So now that we have talked about encryption, let me talk about Amazon Data Lifecycle Manager, DLM. So when we thought about DLM, it was started from sort of the challenges we have heard from customers who run their own solutions for taking snapshots. And some of the common issues we've heard is, let's say you're doing an audit on your snapshot cost, and you're figuring why it costs so much. And you figured, hey, I have a lot of forgotten snapshot that's incurring costs for me. I have no idea what these are for. And why did I not delete them earlier? We also see cases where scripting bugs lead to under or over retention of snapshots. And lastly, for some of our customers, they need a multi-scheduled snapshotting. So taking some daily snapshots for backup, taking some monthly compliance snapshots for compliance purpose. Each are retained with different retention schedule. And it's just a complex management system. So customers have came to us and asked, hey, can you make this easier? Can you make the creation, retention, and deletion of snapshot easier? And that's why we created Amazon Data Lifecycle Manager. So Amazon Data Lifecycle Manager is a tag-based backup solution, meaning that for volumes that you want to be implemented with a DLM policy, you can tag it. And in addition, it's policy-based, meaning that you can set up DLM policies to specify how frequently you want to take a snapshot, how long you want to retain the snapshot before deletion, or if you want to archive it in our archive tier, when you want to move this snapshot to the archive tier and for how long. So using DLM, you can completely automate the scheduled creation of snapshot, the retention of snapshot, deletion of snapshot, and archive of snapshot. And in addition, you can use IAM policies to control access to these DLM policies. And lastly, DLM is completely free to use for all of our customers. And so with DLM, let's go back to our initial pain point, which is I have a bunch of old snapshots that I forgot to delete. With DLM, that problem will not happen because all your snapshots will be deleted according to the retention schedule. Now let's look at how to use DLM on the console. Here you can see that I added tag to a volume vault type that I want to apply DLM policies. And here in DLM, you can select whether you want to target volumes or instances with this policy. Instance, when you run the workloads with a single instance with multiple EBS volumes. Here we put in a volume tag, which is vault type. And here we show the console screen for scheduling. You can choose different type of schedule. Here we show daily, 12 hours. But you can use it as short as 1 hour. And by taking a snapshot every 1 hour, it helps reach, let's say you have a recovery point objective, it helps reach your RPO goal of 1 hour. Now, this part shows how to apply, let's say, multiple policies to a set of resources. So let's say the use case that we talked about, which is daily backup and compliance use backup, you can do so here by adding another schedule. And for retention features, you can specify it in days, weeks, months, or years, whatever you need. And lastly, if it's in your disaster recovery practice to do cross-account, cross-region backup of the snapshot, you can also automate this in DLM. And at the very end, I'd like to talk about archive. Kalyan will go into more details about Snapshot Archive tier, but it is a tier that provides cheaper storage for your snapshot. So using DLM, you can also automate the archiving of your snapshot by specifying, I want this snapshot to be retained for this amount of time in the standard tier. After that period of time, instead of deleting the snapshot, move it to Snapshot Archive and keep it there for a specified period of time before deletion. So now that I have talked about DLM, handing off to Kalyan to talk about Recycle Bin.
Cool. Thank you, Vienna. Now, before I begin talking about Recycle Bin, I wanted to ask as to how many of you have been in a situation where snapshots or Amazon machine images were accidentally deleted? Okay, looks like not a lot of people here. But we regularly hear from customers because they're accidentally deleting snapshots. Now, we launched Recycle Bin at reInvent of last year. We started with snapshots, and then earlier this year, we onboarded Amazon machine images. And we launched Recycle Bin, like I said earlier, because customers like you who use snapshots to protect EBS volumes were accidentally deleting snapshots. Now, the causes of accidental deletion varied from customer to customer. In some cases, they were simply making simple human errors in deleting snapshots. In other cases, they were essentially deploying buggy scripts that were essentially used to manage the lifecycle of these snapshots. And so these scripts would accidentally delete hundreds of snapshots, leading to data loss. And in other cases, customers were simply making mistakes while editing retention policies. Now, regardless of the cause of accidental deletion that leads to data loss, the business impact on our customers was tremendous. So we asked ourselves, how can we make this problem go away for our customers? Or what if we could give our customers a simple tool like Recycle Bin? And that's exactly what we did at reInvent of last year. We launched Recycle Bin for snapshots and AMIs. And so when you configure retention rules in Recycle Bin automatically retains your deleted snapshots based on the retention rules that you configure. Now, retention rules specify a retention period. And this is the period of time for which the snapshots or AMIs are retained in the Recycle Bin before being permanently evicted from Recycle Bin. So if you happen to accidentally delete a snapshot, you can recover them from Recycle Bin before the retention period expires. Now, in terms of pricing, we made pricing very simple. Snapshots in Recycle Bin cost the same as snapshots outside of Recycle Bin, so it's easy for you to think about them. And in terms of restrictions in terms of IAM permissions, we've also provided IAM permissions so that you as an administrator can control who can actually call these retention rule APIs, as well as access to the resources in Recycle Bin. So how does Recycle Bin work? At a high level, you can think of it as in 3 simple steps. Step 1, you need to configure retention rules in the new Recycle Bin console. These rules could either be an account level rule or a tag-based rule. And I'll talk about the differences between those two in a minute. And now once you configure these retention rules, and if you happen to delete resources that are governed by these rules, those resources will automatically flow into recycle bin and stay in recycle bin for the retention period that you configured. And if you happen to accidentally delete them, you can recover them before the retention period expires. So pretty simple and straightforward experience. So now let's look at how to create and manage these retention rules. So first of all, you obviously need to consider which resource are you going to protect. Are you going to protect snapshots or Amazon machine images? And once you figure that one out, you need to then think about retention time or the retention period. Now, customers over the last 1 year, what we've observed is that they're retaining snapshots or Amazon machine images for anywhere from 3 to 7 days. And that's because that's the length of time before they realize that they've accidentally deleted a snapshot. So they essentially configure the retention period anywhere from 3 to 7 days. So once you figured out the retention period, you need to think about whether you want to create an account level rule or a tag level rule. Now, if you're a customer who wants to protect all of their snapshots or armies in their production account, then you would likely want to use an account level rule. Most of our customers use account level rules because they care about all of their resources in their accounts. But if you're a customer who's worried about costs or you want to optimize costs, then you can protect a subset of your resources based on tags and using the tag level rules. So 2 different options. Okay? Let me walk you through the console experience. So this is the recycle bin console that we launched at the launch of the feature. Here, I'm trying to create an account level rule in the recycle bin console, and I'm trying to protect all of my snapshots within my account, and I have specified a retention period of 2 days. Alternatively, I could also use the CLI to essentially create the same rule and specify the parameters. In case of a tag level rule, this is an example of a tag level rule. Here I'm trying to protect snapshots with the tag rbin test1 because I only care about protecting those snapshots with that particular tag, and I want to retain them for a period of 1 day. Again, I can create these same rules using CLI as well. Now, once I've created these rules, I can list the rules obviously in the console, but if you wanted to list the rules using CLI, you'll have to use the list rule command or the get rule API to get more details about each of these rules. Okay? Now let's look at how to manage the resources in the recycle bin. When you're managing resources across snapshots, you'll have to deal with both the snapshots console as well as the recycle bin console. In this case, I have a couple of snapshots, test snapshots listed on the snapshots console above, and I have no snapshots in the recycle bin console. Now, let's assume I want to delete one of these snapshots. This snapshot has a tag of the dev resource tag. And once I confirm the deletion, during the delete snapshot workflow, essentially recycle bin looks at what resource tags have been applied on this particular resource, and also what other rules have been created by the administrator. In this case, I've created a tag level rule that specifies that any snapshot with a dev resource tag should be retained in the recycle bin for 3 days. So this particular rule would kick in when you delete that particular snapshot, and then that snapshot would flow into the recycle bin. And essentially be retained for 3 days because this particular rule asks the recycle bin to retain it for 3 days. Okay? So once you delete the snapshot goes from the snapshots console into the recycle bin console. So pretty simple and straightforward experience. Now, if you wanted to list the snapshots in the recycle bin using CLI, we added a new EC2 API called list snapshots in recycle bin, and you could use that API to list all your resources in recycle bin. Next, for restoring from recycle bin, again, a simple and straightforward experience. You would essentially go into the recycle bin console if you wanted to restore a snapshot. And then click on Actions and select a particular snapshot and hit Restore. And once you hit Restore, that snapshot immediately moves from recycle bin into the snapshots console. Alternatively, you could also use the EC2 Restore snapshots from recycle bin API to restore this snapshot. Now, once you restore the snapshot, it's pretty much available instantly to use for creating an EBS volume or copying it to another region or another account. So pretty instantaneous to do the remaining operations that you wanted to perform. Now let's take a look at managing permissions in Recycle Bin. As I said earlier, now we've created IAM permissions so that you can create a new IAM administrator role. Let's call it Recycle Bin IAM administrator role. And you could give that particular role permissions as to what Recycle Bin retention rule APIs that the user has access to, or what other APIs that are relevant to Recycle Bin that the user has access to. Now, this role could be different from the Snapshot user role that typically has access to the Snapshot APIs like create snapshot, et cetera. So for example, here I have a Recycle Bin IAM administrator that has essentially permissions to all of the Recycle Bin rule APIs, whether that's create rule, update rule, or delete rule, et cetera. Now, this role is different from my Snapshot user IAM role. In the past, this particular role only had access to the Snapshot APIs, but now we can give additional access to this particular role. You can essentially give them access to list the snapshots in Recycle Bin or restore the snapshots from Recycle Bin. Now, if you're a customer who's security conscious, you may want to restrict and only give these two API access to the Recycle Bin administrator and not give it to the regular snapshots user. Okay? Now, a new feature that I'm really excited about that we launched last week is the ability to lock your retention rules in Recycle Bin. Now, by locking retention rules, you're essentially preventing rules from being modified or deleted. And secondly, by locking these rules, you get an additional layer of protection, especially for resources that are maliciously deleted, especially in the case of an account breach during ransomware attacks. So, and because the rules are no longer can be tampered with, any maliciously deleted resources, whether that's a snapshot or an Amazon machine images, those will be safely retained in the Recycle Bin so that you can recover those resources back once you gain access control of your account. So if you're worried about ransomware attacks, if you're worried about malicious deletions, this is a great new feature that we just added last week. So how does it work? When you create a rule, you can create a locked rule. Or if you have an existing retention rule in Recycle Bin, you can edit it and essentially make that a locked rule. Now, you can make a locked rule by specifying an unlock delay period. So an unlock delay period is essentially a period of time where the rule continues to stay locked even when an administrator or a malicious user tries to unlock it. So, and by the way, a locked rule can only be usually unlocked by a user with unlock API permissions. But if a malicious user tried to unlock it, those rules would essentially continue to stay locked because there is an unlock delay period that was configured during the rule lock creation. So pretty powerful feature to protect against ransomware attacks as well as malicious deletions. So next, let me talk about some considerations for using Recycle Bin. Today, you get almost up to 250 rules that you can create in Recycle Bin. So that's pretty generous in terms of the number of rules that you can create. In terms of order of precedence, if you have multiple rules, the rule with the longest retention period wins in terms of evaluating when you have multiple rules that need to be evaluating to govern against a particular resource. In terms of fast snapshot restore, which is a feature that is essentially used by customers to restore quickly, that feature gets disabled when a resource moves into Recycle Bin. Similarly, snapshot sharing is also disabled in terms of sharing permissions get disabled, but the sharing permissions are automatically restored if you move the resource back from Recycle Bin to the snapshots console. Now, apart from restore and other actions that I talked about in Recycle Bin, the only other permissions that you have or actions that you can take on resources in Recycle Bin are ability to add, modify, or delete tags on your resources in Recycle Bin. Okay? So before I move on to the next topic, I just want to get folks to have some key takeaways. Please evaluate the business risk of loss of data from either accidental deletion or malicious deletion, and go enable Recycle Bin today. It's been proven time and again for many of our customers to be a very valuable feature against both accidental deletions as well as malicious deletions. Okay, so that was Recycle Bin. The next feature that I'd like to talk about is Snapshots Archive tier. And before I continue talking about it, I wanted to know as to how many of you here have a need for storing snapshots really for a long term due to compliance reasons or other reasons. Okay, cool. Looks like a couple of you can relate to this particular topic. So we launched EBS Snapshots Archive tier as a new tier of snapshots after almost 13 years last year. Now, until then, we only had one tier of snapshots, which was Snapshot Standard tier. And we launched this archive tier because many of our customers, like you, wanted to retain their rarely accessed snapshots for the longer term due to compliance reasons or other reasons. Okay. Now, one such interesting customer was Johnson & Johnson. They had a very unique challenge. They wanted to store more than 100,000 of their snapshots coming from virtual desktops running on AWS workspaces. And they wanted to store these snapshots for more than 20 plus years because of legal and compliance requirements. And they also wanted a solution that was simple and a native AWS solution. Now, earlier this year, they partnered with us as well as the AWS Lambda team to write scripts, and they successfully migrated all of their snapshots that they wanted to migrate, all 100,000 plus snapshots, into the archive tier. Now, not only did they complete the migration, they also integrated both the snapshots in standard tier as well as in archive tier with their e-discovery workflows, which is something specific that they have inside of their company. Now, the benefits obviously are that they got a solution that was essentially, met their legal and compliance requirements, and they got a solution that was a native AWS solution. But they also are going to save about $1 million in terms of projected savings annually because of this migration to Snapshots Archive tier. In terms of how Snapshots Archive tier works at a high level, like I said, Snapshots Archive tier is designed for long-term retention. So it has a minimum of 90 days to store the snapshots in the archive tier. In terms of differences between a snapshot and archive tier versus a standard tier, a snapshot and archive tier is a full backup only. It does not support incremental snapshots, whereas snapshots in standard tier support incremental forever snapshots. So that's a pretty big difference. In terms of retrieval time, the retrieval of snapshots from an archive tier to the standard tier can take anywhere from 24 to 72 hours, depending on the size of your snapshots. And 72 hours is typically for a 64 terabyte snapshot. Now, the biggest benefit of all is the lower cost. You essentially save 75% in storage costs by moving a snapshot into archive tier. But the trade-off that you will need to make is that you'll end up paying 3 cents per gig of retrieval charges if you do happen to rarely retrieve that snapshot. So Snapshots Archive tier, low storage cost for long-term retention of your rarely accessed snapshots. So in terms of how it works, there's one single API that you need to call, modify snapshot tier. And by calling that modify snapshot tier on your snapshot and standard tier, you essentially create a full copy of that snapshot, and then you move that snapshot into the archive tier. In terms of restore, another single API that you would need to call, restore snapshot tier, and you could restore the snapshot from archive tier into the standard tier. You have two options for restoration. One is what we call as a temporary restore, and the second one is a permanent restore. And I'll talk about that in a minute. So two simple APIs, one for archival, one for restore. Now let's take a look at the console experience for archiving snapshots. Here I have a snapshots console with a bunch of test snapshots. If you notice at the bottom of your screen, there's a new storage tier tab that we've added to the console. And that storage tier tab will give you details about the tier for your snapshots. So let's assume we needed to archive one of these snapshots. Let's pick snapshot test 4. And then it's going to ask you to confirm that you wanted to archive that particular snapshot. Now, if you're a CLI person, you could call the modify snapshot tier API and specify the parameters to essentially invoke the tiering of the snapshot. Now, once you invoke the tiering action and to essentially make the snapshot go from standard tier to archive tier, you can monitor the progress of that tiering on the console in the storage tier tab, or you could call describe snapshot tier status on the CLI to essentially monitor the progress. Eventually, that tiering progress, or the tiering will essentially go to completion, and the snapshot will, from the tier state perspective, it'll go from standard to archive tier. Okay? So pretty simple experience in terms of archiving a snapshot. In terms of restoration, you need to remember a couple of things. If you wanted to use a snapshot in archive tier to create an EBS volume for whatever you needed to do, you first need to restore that snapshot from archive tier into the standard tier before you could actually use it to create an EBS volume. But obviously, so you need to plan ahead because restoration is going to take time. It could take anywhere from 24 to 72 hours. And then you also need to think about whether I want to restore this temporarily or you want to do a permanent restore. If you wanted to do a temporary restore, you could restore up to 180 days. So in this case, you'll not only have a copy of the snapshot in archive tier, but you'll have a copy of that same snapshot in standard tier, but for a temporary period of whatever you specify during the temporary restore. In case of a permanent restore, it actually changes the tier state of the snapshot from archive tier to standard tier permanently. And there's no more copy of that snapshot left in archive tier. But you do need to remember that when you restore, there's a minimum of 90 days, so that you end up paying a penalty if you try to restore it before the 90-day period. In terms of restoration, let me walk you through the console experience. Here, I'm going to pick a snapshot, and the snapshot obviously has to be in the archive tier before you can consider for restoration. So let's assume that I pick one of these snapshots to restoration. Next, on the console is going to prompt me for do I want to do a permanent restore or a temporary restore? Or if I'm using the CLI, I could use the restore snapshot tier API that I talked about, and you could specify whether you want to do one of those two options. Next, if you happen to pick a temporary restore, it's also going to ask you as to how long do you want to have a copy of the snapshot in standard tier. Here I'm specifying it for 3 days, but you could specify up to a maximum of 180 days. So once you kick off the restore, either through the console or through the CLI, you can monitor the progress again on the storage tier tab in the console. It shows on the lower right corner the tiering progress, as well as the state of the snapshot. Okay? And then once the restore completes, the snapshot essentially moves into the standard tier. And here, because I did a temporary restore, the console is going to remind me that I will have a copy of the snapshot in standard tier for a period of 3 days because I did a temporary restore. Now, let me walk you through some considerations for using the snapshots archived here. Snapshots archived here is you need to pay some careful attention as to when to archive a snapshot and when not to archive a snapshot. Let me first walk you through some considerations as to when to archive a snapshot. The first example is if you happen to have a last snapshot of an inactive EBS volume, which means that this EBS volume is likely deleted, and you only have the last snapshot of that EBS volume, that particular snapshot is something that we would recommend you to archive. Another example would be if you had the need for regularly archiving snapshots, or let's say you needed to do on a monthly basis for compliance reasons, that would be another use case where you could use DLM or your own scripts to essentially manage archiving of snapshots on a regular basis and create full snapshots for compliance purposes. Now, another consideration is if you have a snapshot with greater than 25% change rate. What do I mean by that? If you have, let's say, 2 snapshots, snapshot A and snapshot B, and snapshot B is the second snapshot in that lineage, and if that snapshot B has greater than 25% change rate compared to snapshot A, that would be a good snapshot for you to consider for archival, especially from a cost savings perspective. And you could figure out the change rates using what we call as EBS Direct APIs, and I'll talk about that when I get to the EBS Direct API section. These are 3 things that you can think of in terms of considerations for archiving snapshots. Now, you also need to be a little careful, in terms of when not to archive a snapshot. So any snapshot that has less than 25% of change rate, we do not recommend you to archive that snapshot because you're not going to save costs on it. And secondly, if you have an active EBS volume that's constantly taking snapshots, we call that an active lineage, and we do not recommend that you archive the first snapshot of the EBS, of that EBS volume or that lineage, mainly because the subsequent snapshots in that lineage could be referencing data from that first snapshot of that EBS volume. So you do not want to incur costs both in the standard tier and in the archive tier. So we do not recommend archiving the first snapshot of an active EBS volume. Similarly, the last snapshot of an EBS volume is something that we do not recommend for you to archive, mainly because the last snapshot is something that you could potentially be using in the case of a disaster recovery. And so we do not want you to move that snapshot to the archive tier and then essentially have to wait for multiple days to recover. And so we do not recommend archiving the last snapshot of an EBS volume. Okay, some other considerations for archival. You need to remember that only the owner of a snapshot can archive and restore a snapshot. Fast snapshot restore, which was a feature that I talked about earlier, that's also disabled when you archive a snapshot. Similarly, sharing permissions are disabled. So if you have a shared snapshot and if you archive that snapshot, those sharing permissions are going to get disabled. Today, you also cannot archive an AMI-based snapshot, and if you have a snapshot that's associated with an AMI, you cannot archive that. But we are considering actively to add this ability to archive AMI-based snapshots in our roadmap, so keep an eye out for that feature. And lastly, we do support Recycle bin for archive-based snapshots. So if you happen to accidentally delete archive snapshot, and if you have retention rules in Recycle bin that will govern those snapshots, Recycle bin will support those snapshot archives, and you can restore them if you happen to accidentally delete them. Okay, so before I move on to the next topic, I just wanted to get some takeaways for you. Snapshots archive tier, you should be using it for long-term retention purposes, especially for compliance needs and saving costs. But you do need to remember as to when to archive a snapshot and when not to archive a snapshot. Take a look at the considerations that I talked about earlier. And of course, you need to remember that restoring a snapshot from archive tier is going to take time. It could take anywhere from 24 to 72 hours. Okay? So that was snapshots archive tier. And this brings me to my last topic, EBS direct APIs. But before I continue, how many of you have heard of EBS direct APIs or used EBS direct APIs? Okay. Looks like not a lot of people have exposure to it. So we launched EBS direct APIs in 2019 because many of our customers wanted a simple and a cost-effective way to read and write directly to an EBS snapshot without creating an EBS volume. It has two sets of APIs. One is write APIs, and another one is read APIs. The write APIs are used for migrating data from on-premises to AWS as EBS snapshots. And the way you do it is you essentially call three APIs to move the data block by block into AWS as an EBS snapshot. The read APIs are used by our customers to read data out of a snapshot. And if you need to move data from AWS back to on-prem for whatever reason, you could use the read APIs. Or our backup providers use read APIs for essentially accelerating their application backup workflows by using these read APIs. So to get you a little bit more detail as to why we created these APIs, let's look at the scenario before the existence of these write APIs. Here, let's say you had a VM backup or a database backup that you needed to move to AWS. Prior to the write APIs, customers would essentially replicate that data by first copying it to S3. And then they would essentially create an EC2 instance, attach an EBS volume, copy the data from S3 into that EBS volume, and then take a snapshot. So pretty cumbersome and lengthy process just to get an EBS snapshot. Now, if the customer wanted to bring another backup from on-prem, they would have to go through this entire process again by copying the data to S3, copying it to an EBS volume, and then taking a subsequent snapshot. Now, most customers do this because they need to want to keep a copy of their snapshot in AWS for disaster recovery purposes. Now, with the right APIs, that whole workflow of copying to S3 and then copying to an EBS volume, all of that is completely gone. If you have a backup, whether that's a VM backup or a database backup, you simply call the right APIs, and eventually you get an EBS snapshot that you can use for disaster recovery purposes or for other purposes. So completely simplified the way customers bring data from on-premises to AWS as EBS snapshots. Now let's take a look at the read APIs and how customers, what customers try to do before the existence of the read APIs. Here, let's say I have two snapshots, snapshot A and snapshot B from a volume. And if I needed to know what changed between these two snapshots, customers would create two other volumes, let's say volume A and volume B, and they would attach those volumes to an EC2 instance and then write code or scripts to essentially compare block by block just to figure out what changed between those two snapshots. So this was a pretty cumbersome and an inefficient way for our customers and backup partners to figure out what changed between two snapshots. Now with the read APIs, all of that inefficient process and workflows is simply gone. You just take two snapshots, you specify those two snapshots in an API, and that API will return to you or respond back to you with all the blocks that have changed between those two snapshots. So we've completely transformed the way our backup providers are able to calculate what has changed, especially in their application backup workflows. So if you happen to use one of our backup providers, you're likely using EBS Direct APIs. So let me walk you through some of these APIs. On the right API front, we have three APIs. One is the first, if you wanted to bring the data, you need to start with start snapshot. And you can specify either a parent snapshot ID or null, and in the case of if that's the first snapshot in a lineage. Once you've started the snapshot, you can then essentially copy block by uploading that data through put snapshot block API. The block size is 512K from a maximum block size perspective. And once you uploaded all the blocks through put snapshot block, and then you can call complete snapshot to essentially complete the snapshot. So pretty simple set of APIs to upload data from your on-premise to AWS. In terms of read APIs, so like I talked about, there are two use cases. If you simply wanted to read data from a snapshot, you would first call list snapshot block, and that'll give you a set of block tokens. And those block tokens can then be subsequently used to call get snapshot block on a block by block basis to read the data out of the snapshot, and you could write it to a file or wherever that you needed to write to by reading block by block. Now, if you needed to understand what changed between two snapshots, you'll have to use list change blocks, and that API will essentially respond back to you with what are the blocks that have changed between those two snapshots in a given lineage. So we are very excited, and these APIs have proven to be a very standard way of bringing data into AWS, and it's very simplified the way our backup providers and customers are using it for their backup workflows. So pretty powerful APIs. Okay, so to recap and summarize, Vienna talked about the basics of snapshots. She walked you through Data Lifecycle Manager. I then walked you through Recycle Bin, a critical data protection feature, Snapshots Archive tier, as well as direct APIs. Now, if you wanted to learn more about any of these things, please feel free to attend one of these upcoming sessions. They're either workshops or builder sessions or Chalk Talk sessions. You'll learn more about these topics and be able to apply them when you get back to work. And so that's it. That brings us to the end of this presentation. So thank you for coming. We appreciate the time. I know you're all eager to getting to dinner. But before you go, please ensure to complete the survey on your mobile app. Your feedback is very valuable to us. So please do complete that survey. And so have a really good rest of the conference. Thank you once again.